The first one will be FHE Deployment Challenges for Secure Cloud Computing with 4 authors, Flavio Bergamaschi, Anna Maria Costaggi, Tikaram Sanyasi, and Alexander Viand, but it's Flavio who's going to give the presentation. The floor is yours.
Thank you. Okay. Hi, everyone. Be seated, and we're going to start. So this is a project called Project Soteria, which is a collaboration between Intel and NTNU on looking at the deployment issues of FHE. So it's going to be more of a systems talk than a specific FHE talk, but we are going to get into some of the details. Hang on. And that's not my slide. Okay, so because I work for Intel, I have to show this slide on everything that I say while I work for them, right? So, but it has to do with anything I say about performance, don't take it literally unless it's validated, okay? But let's go forward. So what's the motivation for this talk? And we are looking at FHE by itself provides us with some security guarantees, but you can misuse FHE thinking that you are secure, and you may not be. Right, so this is related to a proof of concept that we did for a customer on a full deployment of an FHE solution that involved a cloud system and a client. So we are going to be talking about those aspects, those concerns that the customer has. Look at some differences between what abstractly we talk about, how FHE works. And I'm going to show you a glimpse on how we deploy this for real, for a secure query across security domains. And I'll explain more about that. So why an FHE-based query services? There are multiple ways of doing secure query services. In the context of this talk is an FHE-based query service. It's a client-server application, right? So there is a database sitting somewhere in the cloud, the server side, and there are clients that want to issue queries to those. So what are we protecting here? Basically, several things. One is whenever we ask a question to anybody, you review intent. And you might want to not disclose that intent because it might be sensitive or so. So the client wanted to conceal the intent that is embedded in the query. I give an example. Suppose you are asking about, you want to ask a database and you have to enter account numbers, social security numbers. So you don't want to do that. You don't want the database to learn that you are inputting those predicates for your query. Because there is security, there is intent on the question itself. Now, the server side may want not to know about that because they don't want the liability of knowing what you are asking for. Okay, so then FHE was what was chosen for this proof of concept. based on studies that the customer had done before we even got involved. Right? So, abstract deployment of FHE. So we have a client. The client generates the keys, generates the secrets, generate the data, encode the data, encrypt, send it out to a semi-honest server, which processes the data and replies to the client. That's the kind of a simple scenario that we work mostly academically in research and so on, but when you go to deploy, there are a lot of other things that you need to think about. And this is just some of the things that you have to think about, right? So there is a division of security domains. There is a higher secure domain and a lower secure domain. And there can be even different domains in between, but let's simplify with two. You want to have some key management associated with that, right? Because you have to distribute keys. You don't want to send your public key or your evaluation keys with every query that you send out to a server. The same way, you need to protect your encryption, decryption, encoding, decoding. You might say, well, but this is all public. Let's see some other concerns on the kind of the more public side of that. So what are the concerns? What are the challenges? So FHE is inherently malleable, otherwise we wouldn't be able to compute on FHE ciphertext. If anybody gets hold of your encoding mechanism or your public key, they could inject bogus queries into the system. So you want to protect that aspect as well. You want to mitigate in CPAD attacks, right? So how much information about the ciphertext structure and everything else I give back to the client that issued that question if I'm offering a service. Ciphertext we know are large. We try hard to minimize their sizes, but they're still large. So if you have a client side and a server side, you have to look at, well, how I'm going to transmit these queries, how I'm going to do. The other thing that's important is if you come to a customer, say, oh, HSMs cannot cope with FHE keys. They're going to say, and you're going to come to him and say, well, look, you're going to have to implement this completely new scenario for managing your keys. They're going to say, well, thank you very much. You just spent a few $1 million on the current system that I have. You're telling me that you need a new one. Right, so they're not going to do that. So you're going to have to look at how to integrate the management of FHE keys with existing public key infrastructures. I mentioned protect the encryption, decryption stages of your application. And also, how do you mitigate the risks for integrity of the computation and integrity of the data that is used in that computation, right? And you're going to find out that FHE by itself does not provide all these additional guarantees. So you have to put a lot of effort in there. So here we go. With the scenario that we have, the database is in the clear. It's held on the server side, encoded, but it's encoded clear text. So how to protect that database in there? We encrypt the database with AES. And we provide some attestation to that database. Okay? So you see that many of the components that our FHE uses in here, they are surrounded by this trusted execution environment scenario. Why is that? Because I need to sign the code that runs, like the FHE query engine. I need to provide attestation for the data that goes in there and the code that goes in there. I need to protect my FHE key management side, right? And in this context, we use a combination of hard HSMs and soft HSMs. Why the soft HSM side that we have in there? It's for performing the FHE encryption parts. We also provided this trust execution environment for the engine. And for the managing the keys, we use standard HSM encryptions to protect the keys, evaluation keys, public keys, and secret keys on the client side, right? So it's encrypted within the HSM whenever it needs to be to run an application that requires either the evaluation keys or public keys or the secret key that gets delivered to the soft part, which is the trust execution environment. On the client side, again, we had to protect it in a similar form, right? Because the user on the client, and this is a client institution, so you can see that there is one financial institution on the right-hand side providing services to a plethora of different financial institutions on the client side. And each one will have their own encryption keys and, well, basically FHE keys for doing everything that they need. But a user within the institution does not see any of those keys. The only thing that the user sees is he issues a clear text query to a service that's provided on the client side that does the query encoding, FHE encryption, and sending the data out. On the way back, there's a service that will do that for a user that is authorized to do that. But the user never has code of any of the FHE keys, nor any of the decrypted ciphertext are supplied to the user, because it has to be decoded first. So we try to mitigate in CPAD scenarios that way. The other thing that we had to use when you look at providing a deployment is how do I send my query from my client side to my server side? It's obviously through a secure channel of communication between the client and the server, but also it's a service on the server side. So it's a kind of a many-to-one relationship. So you need a queuing mechanism. You need a messaging mechanism that transfer data in and out, obviously with the right topics, so you can get the responses back. And also on the server side, in this context, is an application that lends itself very well for data partitioning. Right, so I can split my database, I can shard my database in many parts, so I can handle bigger volume of queries. So, as I hope you guys can see, the FHE now became the smallest part on the deployment, right? And everything that you have to put around is something that we normally don't consider, right? And unless you go to deploy, that you try to study, you're going to say, well, if I have all these components with these characteristics, what kind of a number of security can I extract from that? And what are the risks that are involved in this? So we started this collaboration project because what we're trying to do is to understand the full deployment, analyze the risk of each component involved in this deployment, and come up with an index number of how secure or not secure that deployment is, and what are the risks involved, so people can decide how what they're going to do. Case study. So, as I mentioned, it's a disaggregated client-server scenario because we wanted to separate concerns. And when we look at that, we said, okay, so how are we going to implement all that left-hand side on the client side and the right-hand side on the server side? So we went for a Kafka server for messaging, right, which allows us to, based on topics, send messages, but also allows me, using the Kafka server, to load balance the server instances on the server side. On the application, or on the client side, is an application server because I have to, there are several steps on how a client institution would subscribe to the server services. Remember, I said it's a many-to-one. I might have bank A, B, C, D, all wanting to do this, and each one is going to have their own keys, which one is going to have to subscribe to the service. And each of them are going to have to manage their own users, right? The beauty of this scenario, for this use case, is that if I need to revoke a key, I can revoke that quite easily. If I need to revoke a given user access to the client front end, I can do that easily, right? And as soon as that is requested, then that given user will lose all access to whatever they have access to, they had access to. And on the client side, if the client institution believes that there is some risk on the FHE keys that they were using, they can revoke the key, generate new keys, and exchange the keys with the PKI on the service side. So going more in details, right? So we had the evaluation keys, encoded data, query engines, and we basically use topic confirmation. Because messages, you can send message on different topics, and we use in this case a topic per, a different topic per client institution, in a different topic per user within the client, right? So the other important aspect of this message infrastructure is that the user, a person or a system in the financial institution, can issue a query, log out, go back home, come back in the morning, and the system is going to still be functioning, conducting the query, sending the results back, and queuing the results on the client side, ready for when the user comes back. So we had the two sides, the server side, the client side issuing the query, on the way back with what I just said, the consumer, the message consumer, in this case a Kafka consumer, receives the results of the queries, stores it in a database in an encrypted form, right? And that is only decrypted when the authorized user requests a decryption service, but he doesn't touch the keys. So it's all done for him on the system. So this way we can mitigate a lot of the issues of leaking FHE keys or people getting hold of the decrypted ciphertext before decoding. So there are a lot of aspects that we can use to mitigate that. So a quick summary on what we try to do. So I try to explain why we need an FHE service and why a query service, because a client wants to conceal the intent in the query. And on the server side, the server doesn't even know what you're asking for, right? Because they can become liable for two things. For one, for knowing what you're asking for, and second, for whatever they answer to the question. So doing it with FHE as I explained, deploying FHE is way more than just the FHE part, because there is all these other components that we don't think about, right? But need to be there for a full deployment. And I show you a simple scenario of a query across security domains. Okay. So I just need to give some acknowledgements to folks that worked on the kind of all that part that people don't usually think when you talk about FHE, right? And if you have any questions, I'll be happy to answer.
Questions for Flavio? Yes, please.
In this example use case, you mentioned many to one. That means that the database itself is not a property of one of the clients. This is sort of a public or at least joint data set that many different clients with different keys can make queries against, right?
Correct. And the other important aspect of the database, because of the structure of the database, what we call the keys for the data, not encryption keys, the keys for searching, they were variable fields. So the length was variable. So kind of playing with the encoding for that is tricky. So one of the techniques that we use in FHE was we developed an algorithm to perform queries where you can break the predicates and you can have logical operations across the predicate. So I could say, find me Flavio, we end this account number and not this security number. So we had all the options to do this combination. So, yeah.
Okay. Yes.
Do you need to touch every record in the database in order not to get information as to what part of the data you're searching? Hence, that would be inefficient.
Sorry, say it again?
When you do the query, do you have does the query have to touch every single record in the database?
Yes. Yes, it's a full table scan.
Hi, thanks for the talk. In your diagram, you have the FHE encryptor, and I suppose you're making an assumption that everything is correct and has been implemented properly in that. Have you given any thought to extra protection around implementation errors within the FHE encryptor?
Yes, so basically, one of the reasons that we use trust execution environments in this context is because we can provide attestation for the code that runs in there, and some elements of protecting the computation from people peering into what you're doing, right? But all the idea, basically the requirement to use the TEs was primarily to get signing and attestation of the code. So the code that gets deployed is the one that's expected to be deployed.
Thank you. More? Oh, one more question.
Actually, two if I can. The first one, if the database is public and there are multiple clients, like multiple banks, does the metadata is also considered private? For example, the service can do frequency attack on the number of queries for a given column or something like that.
So that's a good question. We consider many of the aspects on the database side to prevent that, because one of the issues that was involved in here is, could a client try to just issue do a kind of brute force attack on the database to do queries that would return the entire database, right? Mm-hmm. So that's an aspect that exists, right? But the other aspect of this service is that the database is very ephemeral, right? So the database is being changed on a daily basis.
Okay.
So from those aspects, there's
Another one?
Yes, later. Your project triggers a lot of questions, but I don't think Flavio is going to disappear, so you can keep on
I'll be here, yes.
asking him questions. Now, let's thank the speaker again.